Assalamualaikum warahmatullahi wabarakatuh. My name is Maja from GC to Al-Jazari. Today, I will be covering four related physics topics, which is density, pressure in fluid, and also upthrust or Archimedes principle. I'll explain the basic formula and the concept, and solve an example, and then discuss how it applies in real life. Let's get into it. The first one is not just weight, not just volume, it's density. Density tells us how tightly packed a matter is within an object or a substance. The formula is ρ equals to m per v, or density equals to mass per volume. Density itself is defined as mass per unit of volume. Let's try to get into the question. We have AO1, AO2, and also AO3, which is, in this case, is how it applies in real life. The first one is state the formula of density and its SI units. As I said before, density is defined as a mass divided by volume, and the formula is ρ equals to m per v, and the SI units is kilogram per meter cubic. Then this is how we do. So here we have the mass. The mass is 600 grams, and the volume is 2 times the 10 of the power of minus 4 per cubic meter. After that, we have to convert the mass into kilogram. We can divide it by 1,000, which then results in 0.6 kilogram. And then we do the formula. The formula is ρ m per v. That means 0.6 divided by 2 times 10 to the power of minus 4. This 0.6 per, this can be simplified into 0. It's not simplified, it's actually too hard in it, 0.0002. That means that we have the result of 3,000 kilogram per meter to the power of minus 3. And that's the answer. And we have the number 2, which is to, let me show you the question. The next one is we have pressure. Pressure is pushy but fair. Pressure is a normal force acting per unit of cross-sectional area. The formula being is P equals to F per A, which is pressure equals to force per area. The unit itself is Pascal, which equals to 1 Newton per square meter. So here's an example. The AA1, as I said earlier, define pressure and give its SI unit. You just have to give that the pressure is the force per unit area. And the formula is P equals to F per A, or pressure equals to force per area of cross-sectional area. And the SI unit is Pascal, which equals to 1 Newton per square meter. The AO2 is, the second question is, if the F is equals to 200 newtons and the cross-sectional area is 0.5 meters cubic, then what is the pressure, right? Firstly, it's important for you to write the equation. P equals to F per cross-sectional area, which brings us into 200 newtons divided by 0.5, which equals in 400, don't forget the unit, Pascal, or newtons per meter cubic minus 2. And that will be the answer for A2 and below. Explain why camels have wide feet compared to horses using the concept of pressure. This is how we do it, is we take an example from the other things in life. It's like this. Why? No. A larger surface area means lower pressure, so camels don't sink into the sand as much as animals with smaller feet. If you wears a heels, so the edge of the heels have a smaller surface area, which means the edge of the heels will have the most pressure than the toe where you slip on it. That's how pressure works. So that's out of the way, we can move into the next one, which is pressure in fluid. Pressure in fluids is based on depth involves, is actually pressure, but in fluid or in gas. Pressure in a liquid acts on an object in all directions, like this. The formula itself is P equals to ρ is density, times G, gravity, times H, or depth in here. So we have P as pressure with Pascal equals to ρ, the one that we talked about earlier, density, times G. G, usually, when we're on Earth, it's 9.81 meter second minus 2. But if in the question it was given the gravity, then use the gravity in the question. But if it's not given in the question, then you will need to know the basic of it. That if we use it on Earth, then it will be 9.81 ms minus 2. And then there will be depth, which is this, or height in meter. The pressure is higher at the greater depths in the liquid, resulting in a higher force acting on an object compared to shallower depths. This is the shallower depths, and this is the deeper depths, sorry, which means that the deeper depths have a greater pressure than the shallower depths. So we'll get into the A01 question. Sure, write the equation of pressure in a liquid and state what its symbol represents. B equals to rho times D times H, where rho is the fluid's density, not the object's density, and D is the gravity, and H is the depth. Now we will move on to the AO2. So we're back with a piece of paper. It was given the height or the depth. We should take pressure in fluid. It was given the height or the depth is 20 meters, and the seawater have the density or rho of 1025 kgm minus 3. That's the provided information. But you must know that when it's not given the gravity, that means this is on Earth. That means the gravity will be 9.81 ms minus 2. So let's write it out. It was given. As usual, we need to write down the equation first, which is P equals to rho times D times H. P is equals to 1025, which is the density of the fluid, times the gravity, which you guys must remember if it's on Earth. And so 9.81 times the depth, which is this one. And that will be 209.8. Or you can simplify it by 2.009 times 10 to the power of 5, because it moves back 5 until the 2 is in front of the decimal points, PA. And if you need the PA absolute, which you don't really need, so we just answer this one, 2.009 times 10 to the power of 5. That will be, last one is upthrust. Upthrust itself is the lift within. Upthrust is the upward force that a liquid or gas exerts on a body floating in it. So it's like when you have a ping pong ball, and then you have a surface of water, you place the ping pong ball there. The upthrust, it's what gets the ping pong ball to always floats on the surface of the fluid or of the water. So the formula will be F equals to rho, density again, limit density again, and then G, as usual, if the question doesn't provide you with a G, that means you would have to go with the G of the Earth, or the gravity of the Earth. That will be 9.81 times volume. Volume is specifically the immersed volume of the object. When you have a ping pong ball, the difference of the pressure at the top and at the bottom is what's result in upthrust or buoyancy. The Archimedes principle. Archimedes principle states that upthrust of an object equals to the weight of the fluid displaced by the object. Hello, and we're back with our piece of paper. So firstly, we will have to write down the information given in the question. Okay, so we have here, they given us the volume of the immersed object. It is 0.01 meter cubic, and the density will be 1,000 kilogram per minute. The gravity is not mentioned in the question. That means you have to bring your own initiative and write it down. That means we are using the gravity of the Earth. That will be 9.81 ms. F equals to rho density times d gravity. I'm sorry, excuse me, it's getting late. So we have here 1,000 density of water times gravity of the Earth. 9.81 times the volume, which is the one that's given on the question, 0.01. And this all will be this 9.81 times 0.01 will be 0.098 times 1,000. And then you have this times this, which means you have 98. That means the F will be 98 newtons. And that will be the answer. Together, these principles explain everything from why a ship floats to why a diver feels the pressure underwater. This will make us to come to our closing. I'm Marsha and Maja from JC to Al-Jazari, and that will be all from me. Density, pressure in fluid, and also Archimedes principle. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.